In this video, we are going to be getting into volumes of known cross-sections. So a cross-section, what that is first. Let's look at this one. Region A is bounded by root x, x equals 4, and the x-axis. So I have a line x equals 4, kind of straight up and down. And then I have the x-axis, and then region A is the area bounded by those things. So here is the area of region A right there. Kind of poorly done, filled in, whatever, but we're somewhere there. Right, so that area right there, that is a cross-section. The cross-section is the area of A, whatever that may be. And now I'm talking about volumes. So what we are going to be doing in the first one is we are going to line up squares that are perpendicular to the x-axis. So all that means is that I'm going to have a square, something like this, so that is my base, and my height, it's going to come up out of the page such that there is a square there. So I have an app that I can use for this, if I can find it, where I can change what the shape is. Hopefully it will make sense. Nope, that's not what I want. Come on. Come on. What are you doing? Okay, there we go. I want square cross sections. Okay, so here is my region. I'm going from 0 to 4, where each of these lengths, what they are doing, right, there's my graph. There is the graph from the top. Now if I kind of angle it some, you can see that these are all squares. Right, so that's the small on the left-hand side, the biggest one's on the right-hand side there, and as I go around, here's the flat part down on the bottom. But as I'm going, it is stacking these squares up in order to make a solid, essentially a 3D figure, where every shape that you see, every length is a square. So what they're doing is they're finding the area of each of these individual squares and using an integral, which is the summation of all of the heights from 0 to 4 in this case. They're taking all of those heights from 0 to 4, they are finding the area of that square, and they're adding those squares all together. That's essentially all an integral is, right? It's just a summation of all of those things. All right, so squares perpendicular to the x-axis. So that means that I'm going to take the sum from 0 to 4 of whatever it is, and in order to find the area of one square, well, my base is root x units long, right? From y equals 0 to the function would be the length of my base. So from 0 to whatever point that point is determined by the square root of x. So the area of each square is side squared, so it would be root x squared. So root x squared dx is the integral that I would use in order to find the volume of this 3D figure created. Okay, and if you needed to, you could find all of this stuff. It's still the same integration techniques that we've been using up to this point. The hardest part about all of this stuff is just coming up with the equation that makes it work. Okay, semicircles perpendicular to the x-axis, which was the first spot that actually showed there. But what's happening is I have semicircles that are coming up out of the page. So it's going to kind of have this like dome type effect. So if I look at it, I do semicircle cross sections. Let me do it on the side. Okay. But there's my figure again, and there would be right about there, something like that. Right. That's looking straight on. But if I kind of rotate it to the side a little bit, you can see that those are all semicircles. There's the flat portion. So I don't know what shape you want to call this, but that's what it is. So if I do the area of this, the area of each of them, it's a half circle, So the area is pi r squared divided by 2. Now we need to figure out what the radius is. And since this part is my entire diameter, I need to take 1/2 of that square root of x. So the area of this would be pi, my radius would be square root of x over 2 squared divided by 2. Right, so that's what my radius is. The radius is root x divided by 2. It's half of that height. So I have 0 to 4. I'm going to go ahead and factor out the pi over 2. You can factor out really pi over 8, but root x over 2 squared dx. And that would give me the volume of that figure. Okay, moving on. Hang on just one second. Okie doke. So region B is in quadrants 1 and 2, bounded by a semicircle with radius of 3. Centered at the origin, and below is the x-axis. Okay, so first thing, I would like to come up with an equation, and this is y equals square root of 9 minus x squared. Right? It has a radius of 3, so I'm thinking back to geometry. A circle has this formula. So if I know that the circle is x squared plus y squared equals the radius squared, the radius is 3, so that's 9, and then I have x squared and y squared. It's only the positive part. If it were plus or minus, that's pretty bad. Whoa, that's even worse. Okay, that's interesting. Okay, well, we're just going to pretend that that's not even close. It looks like a circle, right? Yeah, of course, totally. This part down here would be the negative part, but I don't have that in my graph. So I'm only going to take the positive part when I take the square root. So first part, I have squares perpendicular to the x-axis. So I'm perpendicular to the x-axis, so I have straight up and down. So that means my heights are just the 0 to the function. And I am going from -3 to 3, so from -3 to 3. And then my area of each square is the function squared. So root 9 minus x squared squared in terms of x. All right, this next one is a little bit different, but we need to think about it. So in this case, I have rectangulars where the height is half of the base, and they are perpendicular to the y-axis. So if I am perpendicular to the y-axis, my base length is right here, and they are coming up out of the page something like that. Well, that wasn't good. Come on, go back. Go back! Don't do it! So they have something like that where they're coming out of the page there. So this base length, the area of a rectangle, is just base times height. So in this case, 1/2 base squared, because the height is 1/2 of the base. So if I make that substitution, it's just 1/2 of the base squared. So in order to do this, I need to figure out what this entire base length is. It is symmetric, but it's also in terms of y, because it's going sideways. So it would be much easier if we had this in terms of y. So if I rewrote my equation, I could have this right part over here is the square root of 9 minus y squared, and this left part is negative square root of 9 minus y squared. So if I add those two together essentially, but remember, instead of going negative, well, we could also do top function minus bottom function to find the area there. So if I do root 9 minus y squared minus the negative root 9 minus y squared, then this would come out to be 2 root 9 minus y squared. That would be the length of my base. Right, which makes sense as well because this is symmetric. So this length is equal to this length. So it's essentially just saying like I am doubling the right length on the, the length on the right side. So now since I'm writing it in terms of y, I'm talking about the height as it bases from the y-axis. I need to have my integral in terms of y. It's going from 0 to 3. and it has 1/2 base squared. So 1/2 2 root 9 minus y squared squared. That's the setup. You would solve it just like any other integral that you would have. You are just integrating in terms of y now. Okay. Let's see. Square is perpendicular to the y-axis. I have these two lines. Y equals 4. So I'm talking about this region here. Okay. And I am going perpendicular to the y-axis with the first one. So just like in my last one, I'm going to want to write this in terms of y. So I'm going to make this x equals root y up here, x equals negative root y here. So notice they also have symmetry there. Okay, so my first one, I'm going from 0 to 4, and the base length is 2 root y squared dy. All right, so the base length is just 2 root y. That would give me this distance here, and then I am squaring it to find the area of my square coming out of the figure there. Okay. Equilateral triangles perpendicular to the y-axis. So on this one, I have an equilateral triangle that's coming out where my base is still actually the same, right? My base is 2 root y. So now you just need to know the area of a equilateral triangle, which is root 3 side squared over 4. So all I need is that 2 root y is my side. So I'm still going from 0 to 4. I will factor out the root 3 over 4. Side squared would be 2 root y squared dy. Alrighty, one more. This one can be a beast, I think, if I remember correctly. Okay. Square is perpendicular to the x-axis. Well, at least we're going to the x-axis in both of them. But my square is going to be coming out of the page like that. So for sure, my base length is the top function minus the bottom function, so x plus 2 minus x squared. I guess this isn't that horrible. I need to verify where they are intersecting. It looks like -1 and +2, but let's make sure. So let's find their points of intersection. Yep, so it's +2 and -1. So I will be going from -1 to 2, and they are squares, so I just need the base squared. So I have x plus 2 minus x squared dx. All right, rectangles of constant height 2 units perpendicular to the x-axis. So the area of a rectangle is still base times height. But in this case, my height is always 2. So all I need to do is do the integral from -1 to 2. My height is 2 times my base, which would be x plus 2 minus x squared dx. Actually, it wasn't that bad. Okay. Do we have an area D? We do not. That is it. Well, we did 4 of them though, right? A, B, C, C. Oh, well, we did C twice. Okay, so that's the volume of cross sections. Most of the time when you guys see this on the AP test, if you actually have to evaluate, they will give you a calculator, unless they do something basic like that one up here, where you could just rewrite this as 0 to 4, x dx, and then it's not so horrible. What is that, 8? Something like that. So most of the time they will give you a calculator, or more than likely what they will do is they will say set up, but do not evaluate an integral that represents the area of the cross-section, blah, 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 blah. So most of the time, if they get super weird, you won't have to do it anyways. I look at that one. That was not horrible. I guess none of these are really terrible. This one here would be kind of a pain, but you would just need to distribute and get to something with, I believe, x to the fourth, 4, 3, 2, 1, 0, 5 terms, and then do the antiderivative. Use substitution wouldn't really work for that one. Yeah, so most of the time you're just going to be asked to set them up. But other than that, you have some homework, get some good practice. We have one more big section to learn, and then you guys have made it through. All right, let me know what questions you guys got, please. I don't know how to help you unless you ask questions. All right, talk to y'all soon. Bye.